So as you know, an atom has a nucleus in the center and electrons move around it in specific orbits or shell. Take silicon for example. It has an atomic number of 14, which means it has 14 protons in its nucleus. And because it's a neutral atom, like all elements on the periodic table in their natural state, it also has 14 electrons to balance out those protons. Let's distribute these 14 electrons in their energy levels around the nucleus. The first energy level can hold up to 2 electrons, so we start by placing 2 there, and that shell now is full. Next, we move to the second energy level, which can hold up to 8 electrons, so we add 8 more. That gives us a total of 10 electrons so far, and since silicon has 14 electrons, so we have got 4 left. Those last 4 electrons go into the third energy level, which becomes the outermost shell. The outermost shell is called the valence band, and the 4 electrons sitting there are called valence electrons. Well, now there is another energy level above that. It's normally not occupied by any electrons, and we call that the conduction band. For an electron to become conductive, it needs to gain enough energy to jump from the valence band up to the conduction band. Once it makes that jump, it's free to move, and that's how it can conduct electricity. But here is the thing. Between the valence band and the conduction band, there is this gap which called the band gap, or sometimes we call it forbidden gap, because electrons cannot exist in that space. They either stay below it or jump completely over it.